Sateliții constelației Copernicus, cu care suntem familiarizați astăzi, își au originea în 2004, când s-a propus crearea unei componente de observare spațială. Acordul semnat între Comisia Europeană și Agenția Spațială Europeană a pus bazele familiei de sateliți Sentinel. Datorită tehnologiei și designului de ultimă generație, au jucat un rol esențial în poziționarea Europei ca lider mondial în observarea Pământului. Lansat de la Centrul Spațial Guyana din Kourou, Sentinel-1A a fost primul satelit Copernicus care a ajuns pe orbita polară pentru a oferi imagini de zi și de noapte pentru servicii terestre și oceanice. În 2015 au fost lansate Serviciul de Monitorizare a Mediului Marin și Serviciul de Monitorizare a Atmosferei. Iar 2018 a fost anul începerii operațiunilor celui de-al 6-lea Serviciu Copernicus, serviciul privind schimbările climatice, și ale serviciilor de acces la date și informații. În noiembrie 2020, Sentinel-6A a fost al 8-lea satelit care a ajuns pe orbită și care se concentrează pe oceanografie, creșterea nivelului mării și studii climatice. În viitor, componenta spațială a programului Copernicus se va extinde cu încă 6 misiuni.
Which are, in your opinion, the greatest achievements of the Copernicus program in these 25 years?
Well, probably the biggest achievement is linked to the data license of Copernicus, in my opinion, because has made possible sharing millions of data without any restriction. So everything that is done by Copernicus comes with the Copernicus license, which means that the data is open and free and easy to use. So that for me is probably the most important element of the entire program. Now, the program goes way beyond the data license. It's about designing really new and innovative missions, satellite missions, new sensors, launching those satellites, retrieving the data, and then making the data available, transform this data into something that the user can deal with. So maybe I started with the data license. I mentioned the sensor, and probably the third most important element and the core of the Copernicus program in many respects are the services. One of the important elements of Copernicus is really the existence of these 6 services covering the ocean, the land, emergency, security, atmospheric monitoring, so pollution and climate change. These make, in my opinion, all the difference for this program. There are several. So at the celebration of the 25 year, we were asked to bring one success story among the many we had, and I decided to focus on the European State of the Climate report. So this report was the first regional report on the state of the climate to be produced. We are the 6th edition, and over the year it evolved, it became more operational and attracted every year more attention from the media, but also from the general public and from the policymakers. So we've just released the 2022 edition, so looking at the last year, which in Europe has been the warmest summer on record, with almost half a degree warmer than the previous warmest summer, that was 2021, a year of widespread drought and so on. And that report, so the report that we issue on Earth Day in April, attracted really an unprecedented amount of media attention. So we had of the order of 100 interviews in the first week or so of the report being released. So this is certainly a good success story. The other one that comes easy to mind is just the size of our community of users. So as you probably remember, maybe some of your users remember, the central piece of what we do is the climate data store. So that's the centralized access point to the data on climate. And I remember when we opened the climate data store a few years back, and we were excited to have 100 users registered and then 1,000 users. Well, probably later this month, we will reach 200,000 users. And we respond on average to 1 million data requests per day and deliver to these people something in the order of 150 terabytes of climate data, quality control climate data every single day. So these for me are all measure of successes, and I'm very proud we managed to achieve those.
What is your next objective?
Well, there are two that may be worth mentioning here. One is directly linked to the climate change service, and the other is more indirectly linked, but equally important. The first one is attribution, is the ability to look at an extreme event of some sort and rapidly, so in the space of few days or weeks, analyze the event and come up with an estimate or an understanding of how much that kind of event have been, if at all, have been made worse by climate change. We are thinking of doing it first for heat waves, but potentially over time extend it also to other hazards. And there's been just recently a group of scientists who has done an analysis of the flooding in the Emilia-Romagna region, one of the worst flooding in certainly recent months, possibly in recent years. And they concluded that actually these kind of floods have not been made worse by climate change. So it was a negative result. And I think these negative results are equally, if not more important than the positive one. Not everything is linked to climate change. We know that certain classes of phenomena will get worse, more frequent, and flooding can be one of those. But it's not as simple as saying, well, it has happened, it must be climate change. And we need to be rigorous and be able to trace back and understanding what is the impact of our action on these extreme events and be able to say it loud and rapidly, because it's of general interest. The other development is actually happening in our sister service. So this is CAMS, the Atmospheric Monitoring Service. What we look at the moment are the concentrations, so the amount of gases in the atmosphere. And this is not easy. It's technologically quite complex. So you need very good satellite with high resolution and high spectral characterization of the band. But you also need an infrastructure and a modeling system that allows the inversion of this data. So going from the concentration, the amount of material in the atmosphere, to emissions, so the amount of CO2 or greenhouse gases that we emit through our activities into the atmosphere. And this is, the plan is to make it available, to set it up and run it by 2027.
I think the biggest achievement is that the Copernicus program in the span of 25 years started from not that much. If we place ourselves back in 1998, when the idea of Copernicus was created, we started really in a small scale with not lots of capabilities, and then things developed very rapidly. I will pick some example from the domain I'm working on, so the atmospheric composition as part of the atmosphere monitoring service that we manage at ECMWF. So one is actually to have made operational air quality monitoring and forecasting a reality. So back 25 years back in time, there were observation of air pollution, but the forecasts were made on the basis of statistical method, not very good. So in the meantime, the capacity to forecast air pollution, just like weather is forecasted, develop, and the capacity to measure air pollution from satellite develop as well. So that now we have a range of services that can tell everybody in Europe, but also in the world, about the quality of air. So it's really an enormous satisfaction to have been part of this development, and knowing that unfortunately the impact of air quality on today's society is enormous. 7 million premature deaths annually, as the WHO indicates, means that better information of air pollution unlocked by satellite and by models as we operate them in Copernicus helps solving this problem. Another aspect where Copernicus has helped a lot is in the development of renewable energy. In the case of CAMS, we have allowed to develop a range of services to help with the development of solar radiation. And the last example I want to take, it's not yet an achievement. It's in a good shape, I would say. The ambition of one of the key ambition of Copernicus for the coming years is to monitor emissions of greenhouse gases, and particularly emissions of CO2. It's really essential, and the European Union believes it's essential to bring this information about Earth observation-based estimate of human emission of CO2 to see how the different countries are doing with their policies to mitigate CO2. It's and other greenhouse gases. It's the way to help fix the climate crisis that we are facing. It's a big endeavor. It involves, again, new satellites that will be launched in 2026. It involves also lots of modeling developments that we do as part of camps at ECMWF. But I'm very confident that in 3-4 years' time, when there will be the COP discussions on the table of the different countries of the world, there will be figures provided by Copernicus to know where we stand exactly about emission of greenhouse gases. It will be based on observations and not only, as it is done today, on accounting of things, I would say, on paper and to some extent theoretical. And it's so important that very recently, last week actually, the World Meteorological Organization, which has currently its Congress, decided to create an initiative which is called the Global Greenhouse Gas Watch, and Copernicus and ECMWF will be a key contributor, a lead contributor to this effort. So it's not yet an achievement, but I would say in recent years we have done really decisive steps to help European citizens have a better control on the emission of greenhouse gases.
What happened in the last 25 years? What has changed?
So there have been lots of changes in the atmosphere, some for bad, some for good. The one for bad, everybody knows, it's a gradual increase of greenhouse gases. Unfortunately, greenhouse gases have continually increased over the last 25 years. We see some signs in Europe of making this increase slower. So things are starting, but I think they are probably not yet to the level that we would want, which is to progressively go to carbon neutrality, which is a big commitment for the European Union. So unfortunately, it has been 25 years of increase year on year of CO2 and methane, and making this problem of the climate crisis increasingly important. And we've seen in recent years both temperature, global surface temperature increasing, more extreme events, etc. So that has changed a lot. I wouldn't like to take only a bad example or example that didn't go in the right direction. I have two examples that give hope that things can improve. The first one is with the ozone layer. So thanks to the Montreal Protocol that was decided actually before Copernicus started in 1990. The problem of the ozone hole will be behind us. It will still take a long time in the 2060s, but it will be solved. The other area, and maybe it will be a bit of a surprise, is that air quality has improved a lot, especially in Europe, thanks to a number of policies at European level, but also at national level. Air pollution is improving a lot. So the situation now compared to the 90s is much, much better. However, the current situation is not yet at a level where we can be satisfied and stop the effort.
What can we say about this year for the moment? What the analysis show?
Well, this year so far has been quite peculiar in many respects. We had a rather mild and dry winter in most parts of Europe, especially on the Alps and the Pyrenees. These were then, so the situation somehow changed towards the end of the winter, where we saw some intense precipitation on the northern side of the Alps. We got sort of still widespread drought condition at the beginning of the winter, and these continue into spring in a good part of southern Europe, just to change almost overnight from drought to flooding, especially in northern Italy. So, and now there is a reemergence of the drought in some part of central and northern and northwestern Europe. So a complex landscape already that may lead to water shortages in some region. I'm thinking in particular the Iberian Peninsula. And we do know that the temperature will go up on average, so we cannot be sure that whether this summer will be yet another record-breaking summer or not. Is not a given, but there is a clear tendency going forward. So we do expect, on average, the summer temperature of the next few years to get gradually warmer. So we need to be prepared for this kind of event. The other thing that is brewing, if you want, in the climate world, is what's happening in the Pacific at the moment. At the moment, we are pretty close to neutral conditions, so neither one nor the other. But most models, certainly the vast majority of dynamical models, expect an El Niño to come towards the end of the summer, also because of the warming of a large portion of the tropical ocean. On El Niño year, the global temperature reaches its peak. So there was a statement published by WMO a couple of weeks ago and supported by the Elite Center for long-term climate predictions that highlighted the fact that we may well see another peak in this global mean temperature within the next 12 to 18 months. So that's something affecting the globe as a whole. What happens in Europe when there is an El Niño is a bit more complicated than what could happen, I don't know, in Australia or in South America, that are more directly linked to El Niño. But there is an impact also in Europe. For instance, one of the things that we see on El Niño year, and we are not yet in El Niño condition, is that the Mediterranean tend to get a bit wetter than usual in late spring, early autumn. So that's something to look into potentially. And the impact in winter somehow depends on the strength of El Niño. So it's different between a moderate El Niño, which is a concrete possibility, and a very strong El Niño, which is also a possibility at the stage. So probably a bit too early to say, but these are the kind of things that may help us give our user a bit of a heads up on the condition we may face in the coming months.
For this year, what is the trend in the atmospheric carbon dioxide concentration?
So unfortunately for this year, the trend for carbon dioxide for 2022 has been on the increase again, with an average increase for CO2 compared to past year. So no sign of slowing down. And for methane as well, it was quite a large increase, a bit less marked than in 2020 and in 2021, but still a large increase. So it's true that unfortunately we are looking for 2023 and 2024 to be likely again record years in terms of the climate crisis. Yet in the atmosphere, we don't see very clear sign of improvement for greenhouse gases. So that's why this initiative that I was mentioning about monitoring the emissions will put maybe more in the face of everybody that we really need to do something if we want to see this curve of CO2 progressively level off and maybe go down in the future.
Thank you very much for being here for the Romanian Public Television. Good luck.
Thanks.